Okay, so many reactions are there that they are having already very high speed, like that is nuclear fission. Okay, nuclear fission, if you are knowing, so nuclear fission or radioactive reactions, the radioactivity, they are itself very fast. Okay, so what type of reaction we are going to measure, the speed of what type of reaction? Okay, so let's try to understand little bit in the different way. They are saying it is branch of physical chemistry. It is going to be branch of physical chemistry. It is branch of physical chemistry. Okay, it is branch of physical chemistry which deals, what it is going to do, which deals with, okay, deals with the study of rate of different types of chemical reaction, rate of different type of chemical reaction. That is what they are saying, rate of different types of chemical reaction. That is what the definition. Now if you talk about the what is rate of chemical reaction, okay, if I am asking what is the rate of chemical reaction, so that is how can you be able to define the rate. So rate means that is even you are uh, determining the rate of anything. Suppose you are determining the speed of the bike or the speed of the train. How we determine that is how much distance is covered in the particular given time. That is what the speed. If you are calculating the speed of the train, that is how many kilometers is travel in 1 hour. Simply that is same rate is also defined, that is change in change in concentration. They are saying change in concentration. Concentration means that is already you heard about the last class. That is concentration means it can be molarity, mole fraction, molality, like that. The change in concentration, that is amount of reactant, or it can also be reactant or product. Okay, either it can be reactant or product in per unit time. They are saying in per unit time. So in unit time, how much no reactant convert into the product, or how much product is formed, that is what is known as rate. Okay, so either you can write that is rate of reaction, also the suitable term is there, that is change in concentration of reactant or product in per unit time is known as rate of reaction. Now let us try to understand that is how it can be that in the expression, how can you write rate of reaction? How can you write the expression? So rate of reaction you can write that is change in, you know change in concentration of reactant. That is what change in concentration of reactant divided by, that is what will be, that is unit time, unit time. Now if you talk about, that is the same way in the term of product also you can write. So what in the term of product you can write, that is the product concentration when the time passes, the product get formed. Okay, when the time process, product get formed, and reactant, the amount of reactant get decreased. It's very simple. That is as soon as much as the time is getting increased. Okay, as the time is passing, the concentration of reactant is converting into the concentration of product. More and more reactant combined to give more end product. So how can you write this one? The same one, let us try to write down. So decrease in, here you can write decrease in concentration of reactant, concentration of reactant. Okay, reactant divided by, it is going to be time taken. Now what we can do the same way, if it is decreasing, so another thing is going to increase. So it is going to increase in concentration of what, that is product, concentration of product divided by, that is going to be time taken. This is what the very simple concept. Suppose if I am having r for reactant, it is converting into product. Okay, so
Right.
so what is happening if you are writing the rate in term of reactant or in term of product? So if you are writing that is in term of reactant, let us see. So rate is equal to, two way we can write rate is equal to, it is the reactant, so its concentration is going to decrease, so minus sign, and you can write that is delta r. Delta means change in concentration, upon what we can write r, we have to write in the square bracket, because concentration I told you There is a concentration, no? Concentration. This is square bracket. You can write that is molar concentration. Molar concentration means square bracket, or that is you can write mole per liter. This is also the same, or you can write that is molarity. They are the same term. Okay, so square bracket I am mentioning, and then divided by dt means time taken. So here negative sign. What the negative sign is doing here? That is negative is indicating the decrease, and if you are writing the same way, it will be equal to what? Positive delta p. Okay, it is going to be positive delta p upon delta t. Okay, this is what the concept of the rate.
And delta, what is delta R?
That is what I am explaining. Delta
Mm-hmm.
means what? Change in concentration. Change in
Mm-hmm.
concentration. Okay, change in concentration. Now suppose in 30 minutes. Okay, let's see. Delta means what? If you are writing, okay, delta implies always that is change. Delta always implies the change. It means change means that is, if suppose you are measuring the distance, how can you measure? That is final distance minus initial distance. In 1 hour, if you want to measure the distance, how can you? So that is when the time is, initial time is there 1 second, so that is some certain position will be there, and then in
Mm-hmm.
1 hour how much distance is stable. So same they are saying change in concentration. How means change in concentration? Suppose I am having that is time t1. T1 is initial time. This is going to be initial time. Okay, initial time. And then I am writing t2. It is going to be final time. This is going to be final time. Now here the concentration, when the time t1 is there, it can be the concentration r1 will be there. Okay, and here will be concentration will be r2. Let us try to
Mm-hmm.
understand now. Now when you are talking about the rate means what? We are talking about delta r. Okay, this is delta r upon delta t. Now delta r, how we can write? That is final, r final, r final, and minus
Mm-hmm.
that is r initial. It can be r initial. Okay, that is what the change is all about. Now if you are writing the one term, it's not change. So r final minus r initial, and they here that is time also the same way the time is changing. So we can write that is what it is going to be, that is t2 minus t1. Final minus initial. T2 means final, you know, wherever 2 means final. So where that is this final minus initial, that is what is representing by delta. So delta r
Mm-hmm.
upon it is going to be delta t. Since it is the concentration of reactant is decreasing, so it is going to be minus sign. Simple.
Okay. Oh, so it's decreasing. That's why there's a minus.
That is minus sign means decrease in concentration. No, decrease in concentration. And positive
Okay.
sign, if you are talking about, that is increase in concentration. So what that is the here we are using, that is decrease means that is reactant, going to be reactant. And increase means that is which concentration is going to increase, that is the concentration of product. So this is what the point
Mm-hmm.
is all about.
Okay.
Hmm. So here we explained, okay, change in concentration of reactant. Change means the delta. Decrease in concentration of reactant or increase in concentration of product. So same way I write. So delta R means what? You can write, if you are again you are, if you want to write. So what we can
Mm-hmm.
write, that is minus sign will be there, and it can be R2 minus R1. R2 minus R1 means they are going to be the concentration. They are the concentration, R2 minus R1. And here if you are talking about divide by T2 minus T1. Similarly, here negative sign, already I told you that is the concentration of reactant is going to decrease. Or for the product, in the term of product, if you are calculating, so that is it will be the positive sign, and here it will be that
Yeah.
is T2, concentration of T2 minus concentration of T1. And simple downside also it will be that is T2 minus T1. So this is the very basic things, that is rate of reaction. Can I erase this?
Okay.
Can I erase?
Just one second. I'm just writing the last thing now.
Okay, no problem.
Positive T2 minus positive T1 over T2. And so the variable P is known as
Variable means known as change in concentration, delta.
yeah,
Hmm. Yeah.
the change in concentration. And this is final time minus initial time.
Yes.
Okay, got it.
Here I wrote na, this is initial time means t1, the final time means t2. R1 means initial, one means that is it is going to be initial only, and that is this is the final. Always, because final is larger value, so final minus initial we have to do. And in the term of reactant, it is always supposed to be before the minus sign we have to use. Acha, this is the okay, very basic. Let us try to understand. For we are saying for which type of reaction we are going to calculate, for the different coefficient reaction. Let us try to understand for different coefficient reaction. Okay, so they are saying that is rate of reaction depends on coefficient. Okay, so ROR, rate of reaction, R for different coefficient reaction. Suppose if I am taking the one reaction, I am taking from the book here. Okay, what the reaction they have said, that is M1 mole of A plus they are saying that is no, if you are talking M2 mole of B, if they are reacting, it is going to give N1 mole of P plus N2 mole of Q. Okay, these terms are okay product. These are the product, or here is what are there, that is going to be reactant. They are the reactants. If this one, for this type of reaction, rate, how we calculate rate. Okay, so rate can be calculated, rate means ROR. Rate means always wherever the rate term is coming means rate of reaction, they are talking about rate of reaction, can be calculated in individual term, in individual species, in individual species concentration. So they are saying that is you can take the any of this one, this all will be the similar rate. If it is decomposing M1 A, decomposing, the similar will be M2 B. Okay, the rate will be always the same. So let's try to understand what the meaning of this one. I am writing the expression rate is equal to, it is going to give that is 1 upon M1, then it is going to be what we can write, that is delta, okay, A, no, delta A, and this will be the concentration form, and we have to write that is delta T. And what we have to do before that, we have to put the sign minus. Okay, so coefficient is going to divide. This is the, we have to memorize, coefficient need to be divide. Now let's go for the another term. If you are talking about in the term of B, so what we can write, that is minus 1 by M2, and it is the in the square bracket, it is going to be B. This is going to be B, and divided by, it is going to be delta T. And delta terms you can write, that is outside delta. Okay, here whatever delta means change. So here I wrote that is deltas. If you are writing that is another term in the term of product, so how can you write in the term of product? So it will be plus 1 upon N1. The coefficient is going to be divided. So 1 upon N1, and that is here is the delta P. This is in the square bracket divided by what? Delta T. Okay. Delta, that is wherever the square bracket is there, they are talking about the change in concentration. Similarly, you can write that is 1 upon N2, 1 upon N2, and here they are saying that is delta Q. They are going to be delta Q upon, it is going to be delta T. So this is what is the rate of reaction. If this type of reactions are given, suppose any concentration is given, you can calculate the rate of, here is the rate of disappearance of A or B, and that is in the term of P and Q, rate of appearance. So okay, you please make a note of it, because it is going to be useful for you.
Okay, done.
Okay, thank you. So, okay. Now one more term is there, rate of appearance. Okay, rate of appearance. Okay, if you are talking about rate of appearance, means in term of product. In term of product, appearance means what? That is concentration of product is increasing. Now, so in term of product, appearance is always studied in the term of product. So suppose if any of the reaction is there, okay, same reaction I am having, that is m mole of A plus m mole of B. Okay, this is m1 mole of A, m2 mole of B. It is giving that is n1 mole of P plus it is going n2 mole of Q. So these are going to be in the term of appearance because they are the product. Okay, the product concentration is appearance, and this concentration will decrease. So this will be the disappearance. Will it be easy to you to understand?
So that is the disappearance and that is the appearance.
So if you are writing the
Okay.
rate of appearance, so it can be 1 upon n1 delta p upon what, delta t. Okay, this we can write. Now it is in the
Yeah.
term of P, or you can write that is appearance means positive charge, or you can write 1 upon n2. It can be that is delta Q upon what we can write, that is delta T. Can we write this one?
Yes.
If you are writing that is a rate of disappearance, rate of disappearance. So how we can study that is rate of disappearance? So it will be negative side. Negative means disappearance. So 1 upon m1. And here is delta A, this is going to be delta A upon delta T equal to negative sign 1 upon, it is going to be M2, and it is going to be what, delta B upon delta T. Can you be able to understand this appearance and disappearance?
Can we go over the I didn't get the, so what does it mean by like the disappearance?
Disappearance means change in, decrease in concentration. That's simple.
Okay. So
Decrease
that
in
is,
concentration. Decrease in concentration
oh,
means
and appearances increase.
decrease in concentration. It's simple. If suppose, wait, I'm giving you the example, increase in concentration. Suppose we are having the N2 plus 3H2. Okay, it is giving that is 2NH3. Okay, so when time T is equal to 0 means suppose it is there that is 100 mole and 100 mole. Okay, so here is it will be 0 because T is equal to 0, reaction not started. Suppose these are going T is equal to, we are talking about 30 minutes. So 30 minutes means it become 50 mole, it become 50 mole. So it become that is 50 mole air is formed. It means what they are saying, this concentration is increasing. Now product concentration increases, yes, yeah, 0 to 50.
Yeah.
So this become the appearance. Okay, this become the appearance because initially when reaction not started, its concentration was 0. So it appear now, so 50 is appear. And what it become, decrease, its concentration decrease. Decrease means getting disappear, getting at the end it is disappear, all the reactant will finish, so this is going to be disappear. Yes, yeah, no?
Yeah.
Okay, so let me try to write down the one problem, you try to solve this. uh, hmm. What is rate of appearance of reaction? What is rate of appearance of reaction? They are talking about what is rate of appearance of reaction. This is there. And here if you are talking about, we are having that is N2O4. This is going to be gas and it is a reversible 2NO2. It is going to be gas. Okay, this is there. Now they are saying initial concentration they have given. What the concentration they given? Initial concentration of N2O4, you know, initial concentration of N2O4 is 0.46 capital M molar, mole per liter.
Okay.
Okay, initial
Initial
concentration,
part.
0.46 molar falls to, they are saying 0.28 molar. Okay, in 30 minutes. So they have given this one. So 30 minutes, this concentration is falling. Okay, for what? Reactant N2O4 concentration. So they are saying that is what can be the rate of appearance. They are asking in this term, given in this term. Option they have given 12 into 10 power 2. Okay, mole per liter. B number they are talking 1.2 into 10 power 2 and 1.2 into 10 power minus 2 and 1.8 into 10 power minus 1. they all in the term of mole per liter per second. So okay, unit I'll explain later on. Firstly, you try to solve this one. So suppose how can you be able to solve this type of problem? If you see this reaction is something N2O4, here coefficient 1, there is no problem. But here you see 2NO2 is there, here coefficient is different, here is 2 is there.
Yeah.
So if you are writing ROR, so in term of reactant what we can write, that is it will be that is delta N2O4, it will be the N2O4 upon that is delta T. Okay, so here this will be negative sign and here it will be positive sign 1 by 2 and delta NO2, it is going to be NO2 upon delta T, right? Now they are asking what is the rate of appearance. If you are asking rate of appearance in this one, if you are talking about rate of appearance, so change in concentration, so
Yeah, change in concentration over time.
change in concentration of product. Okay, appearance means product. Upon what we can write, that is time taken. Time
Time
taken.
taken, which is 30
Okay.
minutes.
30 minutes. So here is that is rate of appearance ROA is equal to what is change in concentration of product. How can you be right? That is they are talking about delta NO2 upon dt. They are talking about these terms. They are asking this term only. Okay, but they have given this term, they have given both in between there is equal to sign, so we are using this equation from 1. Okay, from equation 1 we are going from equation 1. So here is the concentration of N2O4, how much is changing. See, this is the initial, and because it is reactant initially it will be large and finally it is going to decrease. Yes or no? Finally it is going to decrease. So here this one if I am writing, so this will be the initial concentration, and what is this is the final concentration. Will it be okay to you to understand this? Okay, so here what I am going to write here, you can see if I am writing here, so final minus initial, because here is delta symbol is there, so delta means final minus initial. So final term is what is there, 0.28 minus what will come here, 0.46. Yes or no? Divided by total time they have
30.
taken in 30 minutes, means 30 minus 0, final will be 30, initial will be 0, so directly we have to write 30 equal to 1 by 2, 1 by 2, it is going to be delta NO2, this is the appearance, upon dt. 1 by 2 we have to rate means that is change in concentration upon dt. 1 by 2 is the coefficient. How we are going to use in this equation, you see, if you are subtracting this one, okay, so let us see what the value is going to come here. Otherwise there is one more way to subtract it, minus, you multiply by minus sign. So if you are multiplying by minus sign, it will come 0 point minus 0.28 and minus into minus plus 0.46 upon it is going to be 30 is equal to 1 by 2, okay, delta NO2 upon dt. So if you are solving this one, you solve how much it's coming. You solve this one, how much is coming? 0.18 coming. Here you see that is here,
Zero.
no? Plus 0.1.
0.1.
In the positive, it is coming positive because it is larger value positive. 0.1 weight of 130. Okay, is equal to the same one, 1 by 2. And here is the that is delta NO2 upon dt. Okay, so I am going in the next page. So here is 1 by 2 delta NO2 upon dt is equal to, it is coming 0.18 upon 30. So what is 1 by 2? Send the 1 by 2 this side. You can cross multiply this value. So what is that is, we need only this value. Change in concentration dNO2 delta NO2 upon delta T is equal to 2 will go that side. So 2 into 0.18 upon 30. So it is coming what, 0.36 upon 30.
Yes.
So it will come one time it will not go. Firstly, we need to remove the decimal.
It is 0.012.
0.012. So you place the decimal this side on the right side. So 1.2 into
Yeah,
10 power, it is
1.2
going to be
10 to the
minus
negative
2 molar.
Yeah.
Okay. Firstly, you see the options. See, this one option, I think C1 is correct.
See.
Hmm. Can you understand this?
Yes.
Okay. If you want to write, please, you can write.
Yeah. I've written it.
Okay, okay. Written.
Yeah.
This side also.
Yeah.
Okay. I'm giving you the very simple one. One more problem. You try to solve it out. Okay. Person, they are saying observe. Okay. They are saying observe the following reaction. Observe the following reaction. Okay. Observe the following reaction. And they are saying 2A plus B, it is going to C. Okay. The rate of formation of C. The rate of formation of C. Rate of formation. Rate of formation means rate of appearance. Okay. Rate
Right.
of formation of C is 2.2 into 10 power minus 3 mole per liter. Okay, mole per liter per minute. Okay, I will explain that is what the unit here. Okay, per minute. What is value of? They are saying what is value of what the reaction, they are saying minus dA upon delta T. They are asking what is value of minus dA upon delta T in same term. So same term they are asking. You just please calculate. Okay. I'm giving you the option 2.2 into 10 power minus 3. B number they are talking about 1.1 into 10 power minus 3 and 4.4 into 10 power minus 3, 5.5 into 10 power minus 3.
And rate of appearance is in products, right?
Hmm. This is the rate of disappearance they are asking actually. Because if you see in your question, what is there? 2A plus B, it is giving to C. So rate, if you are writing rate, so what we can write 1 by 2 because coefficient is there. So delta A upon delta T, it will come. Okay, and here it will be the negative sign. Then if you are writing in the term of B, it will be equal to. So delta B, it will be delta B upon it is going to be delta T. And again, it is going to be positive. So it is going to be delta C because there is
Over
no
delta T.
delta T. So this they have all are equal sign are there. Everywhere there is equal to sign. Okay. So if there is everywhere equal to sign, so we can compare anyone. They have
Yeah.
given C1. They have given C1. This is what the rate, na? C1 they have given. They are saying to compare with the first one.
Yes.
It's very.
So this can be 4.4 times 10 to the negative 3.
Yeah. This is the option. Got it, na?
Yeah.
Okay. So this type of question is going to come. Okay. See, one reaction they have given question. 2SO2 plus O2, they are giving 2SO3. Okay. They are saying that is the value they have given DO2. D for you can write here is delta in the term of delta. They are saying delta O2 in term of delta O2 upon delta T is how much they are saying 3.0 into 10 power minus 4. Okay. Then they are saying then find ROR in term of, they are saying in term of SO3, they have said. Then find ROR in term of SO3. So option I will be able to write here plus 3 into 10 power minus 4 plus 2 into 10 power minus 6 plus 1 into 10 power minus 1 and plus 9 into 10 power minus 6. Okay, these are there. So guess it out. Which can be the correct answer?
So delta O2 is in delta T is equal to this. So this is going to be
Hmm.
uh so this is 2, so that's going to be O2 is that, and this is going to be 1 over 2. So if you compare to, SO3
Hmm.
to O2, then we will get this is going to, I don't, is, oh, is it just 6 or a 9? Because the answer I got was 6 times 10 to the negative 4.
Yeah, this is the answer only. So you understood very easily. Got it.
Mm-hmm.
You need to explanation or this is okay for you?
This is okay. So what I can even explain it to you. So what I did is that there are three components, and I can compare 1 over 2 delta SO3 divided by dt is
Mhm.
equal to
Yeah.
delta O2 over delta T. So I just multiplied by 2 and
That's correct, correct, correct. Great, 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 great. Okay, next one is types of reaction. Very small types of reaction they are talking about. Types of reaction based on ROR, based on ROR. Okay, on the basis of rate of reaction, that is, on the basis of rate of reaction, types of reaction can be are three types. Okay, they are saying there are three types of reactions are there. First one is instantaneous, instantaneous, instantaneous rate of reaction. Okay, a rate instantaneous rate of reaction means complete very fast. Okay,
mhm,
completed. Okay, very fast, very fast. They are going to complete it very fast, very fast. It means in no in short period of time, in short period of time, you know? So if it is
mhm.
completing very fast short period of time, you will not be able to calculate the speed. We are not going to do the reaction. Suppose what the reaction if you are talking about, that is the example. If you are talking about the radioactive emission, okay, radioactive emission, okay,
Mhm.
we are not going to calculate the rate of radioactive emission, because yeah, nuclear fission reactions are there, they are very very fast. You can't do anything, you can't calculate in the laboratory. So we are not going to complete, but that is what is the instantaneous rate of reaction, completed very fast or in short period of time. Okay, so that is another reaction is there. Okay, slow reaction, that is what very slow reaction, very slow reaction. Okay, very slow reaction means takes takes too many years. Okay, they are going to calculate, take too many years or month. Okay, month to complete. Okay, this is, so they are the they are the very slow, so not calculate, you know. So
Mhm.
no, it if it is taking very slow, so how you can calculate in the laboratory? It's very difficult to calculate if any reaction is completing in 2 years, 3 years, you know. So you are not going
Yeah.
to calculate. Now one example is what there, that is corrosion is there. Okay, corrosion, if you talk about corrosion of metal, it's never complete in 1 month or 1 year. If you see the plant or the industrial, wherever the industry is there, power plant are there, like in one say there are too many power plant are there, they constructed 40 years 50 years back, the pipelines are same, you know, nothing changed there, you know, they are as it is. So
Mhm.
if they are as it is means the corrosion is the slow process. It is taking, that is, although they are getting corroded little bit, they may be corroding, but how it is slow, it's too much slow. Yes, yeah, no. So we are not going to calculate the rate of reaction of that type of reaction. Getting my point?
Mhm.
Last one is the moderate reaction. Moderate reaction, moderate reaction means what they are saying, its speed, its its speed is, its speed is intermediate. They are saying intermediate between very fast and very slow, very fast and very slow. So its
Okay.
speed is very fast or very slow. So we can calculate like that. Chemical reaction in lab, whatever the chemical reaction are there in lab, whatever we are studying, that we can do chemical reaction in lab.
Mhm.
Okay, So like whatever the chemical reaction, like we can study the decomposition we can write study, or that is if you are writing that is decomposition, then you can write formation reaction or any neutralization reaction. This we can study where in the lab. So there are three types of reactions are there based on the rate of reaction. So rate of reaction can decide that is how many types of reaction is there. So that is the rate of reactions are three types are there, that is instantaneous, moderate and very slow. Instantaneous rate of reaction completed within no time, so we are not going to calculate. Moderate rate of reaction, it is the medium speed that we are going to calculate, and very slow rate of reaction that also take many years to complete, so that is we are not going to calculate this also. Okay, now
Mhm.
next point is there we are having, that is order of reaction, going to be order of reaction. Okay, firstly you try to understand unit of rate of reaction, unit of rate of reaction, unit of rate of reaction. So when you talk about the unit of rate of reaction, unit of rate of reaction, so that is what is, that is rate. You see rate is there, what is there here is the, we are writing that is change in concentration. Rate means what, that is change in concentration. Here we are having change in concentration divided by what we are writing, time taken, time taken. Now
Yep.
change in concentration, it is what, mole per liter. Okay, it is talking change in concentration means molarity. So it is going to be mole per liter divided by what, second. So if you are talking
Mhm.
about that one, that is, it is going to be mole per liter per second. So this is what the unit of rate. Yes or no?
Yeah.
Okay, now next one is the order of reaction. We are going to study order of reaction. This is order of reaction. So order of reaction means the sum, what they are saying, the sum of the sum of power of concentration, the sum of power of concentration of reactant, the sum of power of concentration of reactant, okay, concentration of reactant is known as what is going to be known as order of reaction. Okay, order of reaction. They are saying the sum of power of concentration of reactant in rate law. Reactant you can little increase, reactant in rate law, in rate law. Okay, rate law is known as order of reaction. Okay, so if suppose that is, if I am having that is rate is equal to, if I am writing rate is equal to, here is the rate law, I am writing rate law, one small term is there, rate law. So rate law, how defined, rate is equal to, rate is proportional to no concentration, rate is proportional to concentration of reactant, concentration of reactant, reactants. This is, so
Mhm.
concentration of reactants means this one. If you are removing the proportionality sign, so it will come K. So rate is equal to, it is going to be K, and here we can write that is reactant, R. R for reactant, R means reactant. So they are saying that is
Okay.
what is the, what can be the order. So order can be how much power is there. If the power is 1, if the power is 1, okay, what they are saying, the sum of power of concentration of reactant. So if power is 1, so order, if you are writing, order will be 1. If suppose in the
Mhm.
rate law, if rate law, it is the K, they are saying if the power is how much is there, power is 2, so here is order of reaction is going to be second order kinetic. So can you please make a note of it so that we can do the some problem based on it.
Yes. And so what is K? K is the coefficient.
K is the proportionality constant. K is the
Okay.
proportionality constant. Rate law, they are saying rate is proportional to rate law. When you study equilibrium is there in your syllabus. So the rate
Mhm.
law, they are saying that is the rate is always proportional to concentration of reactant. That's it. Rate is proportional to concentration of reactant, molar concentration. So proportional sign they have given. So rate is equal to proportional to concentration of reactant. So if you are removing the proportionality constant, So it will be what? That is the K is proportionality constant. This is the
Okay. Okay, noted it.
Proportionality constant. Can I read?
Yes.
So here you see they are saying, okay, let me write this one. Suppose I am having that is x mole of A plus y mole of B plus z mole of C. They are going to give the product. Okay. So for this reaction, they are saying that is what is the order. So order, how to write the order they are asking. So we have to write the rate term. Okay, rate term. So rate term means they are saying rate proportional to, I am writing concentration of reactant. Concentration of reactant. This is what is the term, concentration of reactant. So how can you be able to write the concentration of reactant in the molar term? So rate proportional to, see it's okay. Equilibrium chapter you are supposed to study before this one. Okay, to study.
Okay.
To study this one, equilibrium is concept of equilibrium is required. So because there is the change in concentration we study, you know, in equilibrium. So rate is equal to concentration of reactant. So that is what is A is there. Okay. So here the law we are writing. Okay. So power it go x, it's the coefficient go in the power. Okay. It is proportionality, na? Proportionality means power.
Yeah.
Equal to we are writing that is different case. And then B it is going to be power y, and C it is going to power z. Okay, this is there. So if you are writing rate is equal to, you can write here is the K. So A power it is going to be x, B power it is going to be y, and C power it is going to be z. So if you are going to write the order means what you told you, that is sum of power of concentration. Sum of power of concentration. Never write that is product, concentration of reactant. Okay, this is defined in the term of reactant. So what will be the power is that is x plus y plus z. This is order of reaction. Can I erase this?
Got it. Yes.
Question. Here we are writing the question. Okay, you see the question. What is the question? Question, they are saying calculate the overall order of reaction. Okay, calculate the overall order of reaction. Calculate overall order of reaction. This is a number option they have given. Rate is equal to, they are saying that is rate is equal to K A power 1 by 2 and B power 3 by 2. Okay, and B number question they have said that that is rate is equal to, they are saying K A power 3 by 2 and B power minus 1. They are asking that is calculate the rate. Calculate and tell me.
So, calculate the overall. So will this be B?
How many value order? If you are writing that is order. Here is very simple.
Oh,
Order they are asking. Calculate the overall order. So how can you calculate the order? Okay, order. If you are talking about E. Okay, so order if you are writing here. So that is order means sum of power of concentration. Sum of power of concentration.
oh, I got
Hmm.
it. Okay, okay.
Hmm.
So A will be 2 and B is going to be 1 over 2.
This is going to be 2, that is correct, and it is 1 over 2. That is going to be order here is that is 1 by 2. So already this is a very good only. Okay. Now what we are having, let me check in your book any other things or what are the topics are there. Wait. 1 second. I'm searching the. It's not. Okay. Here they are saying that is rate constant. They are order of the rate constant. They are saying unit of. I'm changing that is unit of rate constant. They are asking unit of rate constant. Okay. Unit of rate constant K. Okay. Unit of rate constant K. Okay. So when you are talking about the unit of rate constant, so suppose the order of reaction is possible, anything. Order can be 0, first order, second order, third order, or fractional order, anything possible. Okay. So they are saying that is unit of first order reaction, or the zero order. Okay. So
Yeah.
that is, firstly you try to understand zero order reaction, then I will explain it. Zero order reaction. Okay. Zero order reaction. If there is no change of, if there is no change in, if there is no change in concentration of reactant, CO. If there is no change in the concentration of reactant, then it is zero order reaction.
Yeah.
Hmm.
No change in concentration of reactant.
Yes. So they are saying that is
Okay.
going to be the zero order reaction. Or that is also if the power of concentration, that is one more definition. If the power of concentration of reactant is zero, So if the power of concentration of reactant is zero, then it is zero order. Then it is zero order reaction. Zero order reaction. So how can you define the zero order reaction? That is, if the power of concentration is zero, it is going to be zero order reaction. Can I read this one?
1 second. Okay, yeah. Okay.
Okay. Now that is what you got. If there is the power is one, if power is one, so that is what, that is the order is one. Suppose that is here directly you can understand. R power 0, it means zero order reaction. R power it is going to be 1, so it is going to be first order. Getting my point? First order. If R power is going to be 2, okay, so it is going to be second order. Okay. If R power is going to be 3, so this is going to be third order. Okay. If R power is going to be 1 by 2, it is 1 by 2, so that is half order. That is going to be half order. So order of reaction is defined, that is how much power is there on that. Okay. So got it?
Yeah.
Okay. So unit of, they are saying unit of zero order reaction. Zero order reaction. Zero order reaction. So that is, we reached out. So that is zero order reaction is rate is equal to K, unit of zero order rate constant. Sorry. Zero order rate constant. Okay. So K, and that is reactant power, it will be reactant power is 0. Okay. So how can you be able to write the rate? So here is what is their rate. Rate means what? That is a change in concentration of reactant divided by time taken, this one. And K is what is there, this side. That is, here you see, R is there now. So R means that is, I am writing that is R only. Okay. Let us try to write that is what is the concentration here in the upper term. Square bracket means what? Mole per liter, I told you. Square bracket means mole per liter, right? So here I am
Right.
writing that is going to be mole per liter divided by what is there? Time is there. Okay. Time unit you can write that is second. Time unit is second. So I'm writing that is second is equal to K. And here is the R square bracket 0 is there. That's okay. But what is inside it will come? That is unit will come what? Mole per liter, yes or no? Because square bracket
Yes.
here. So what we are going to do, this mole per liter and this mole per liter is cancel out. So unit of rate constant will be there, that is second inverse.
Okay.
Okay. So if there is anywhere it is written that is second inverse value, so definitely you have to say that is it is the zero order reaction. So now you calculate for first order reaction. Unit of what is the first order reaction? Wait, sorry. You calculate the unit of first order reaction.
So unit of first order reaction.
No, sorry, I'm extremely sorry here. Little bit mistake is there. Okay, what is mistake? Wait. Little bit mistake is there. Extremely sorry for this. Okay, sorry. I want to ask you one mathematics problem is there. Okay,
Yeah.
if suppose 10 power 1 is there, it means 10 into 1. Okay,
10 to 1, yeah.
so it is going to be 10 only. If there is 10 power 2, so it is going to 10 into 10. So it is
Yeah.
going to be 100. What will be the 10 power 0? So 10 power 0,
1.
it is 10 into 0. Okay, that's okay. That we don't do this way. In the mathematics, this is simple. This is the one. Okay.
Yeah.
So here what we wrote here, Sodia, that is a little bit mistake I did here. Okay. So here what is there? 10 r power 0 is there, na? R power 0. So r
That is
power
just
0 means
1, right?
r power 0. It means this is r power 0 means its value is 1, na? Its value is 1. Yes, na? Its
Yeah.
value, yeah. So its value is 1 means simply nothing is there. We are not going to measure in the mole per liter. So here if you are writing that is K and here is into 1. So unit cannot be this much. Unit can be whatever there comes, that is here is unit will be more, liter inverse and second inverse. Okay. Whole liter inverse, second inverse. This is the zero order. Now they are asking that is you calculate first order. So they are talking about rate. Okay. Rate is equal to what we can write, K and R power 1. Now you tell me the value. Now.
Okay, R1.
Hmm.
And we are trying to find the
K value, K. Unit of rate constant K.
So it will just be one, right?
R power 1 means what? Let's see. Let's see. Little bit. It is little bit problematic one. See here, what is there? Mole per liter was there. There is no doubt about it. R means mole per liter, but here power is 0, na? So this become 1. So that because anything power, if there is a
Yeah.
power 0, it is going to be 1 only.
1.
So this as a whole term it become 1, na? As a whole term it become 1. This.
Yeah.
Okay, but in this case rate means what? Rate if you are writing, so initially I told you rate means what if you are writing, so delta R upon it is going to be delta T. Okay, and here is that is K and R concentration, you know very well, R concentration means square bracket is there, na? So what
Yeah,
is R
bracket 1.
concentration? Mole per liter it will be there, divided by delta T. Delta T means
Yeah.
second. Here is equal to K. And this one also power 1 is there. So mole
Also
per
divided
liter.
by mole per liter.
Power 1 means 1 only. There is no problem. Because we are if you what you did 1 now. So the same value came now. So that is what now you see in this one. Now in this one, mole per liter will be cancelled out. Both sides equal.
Yes, liter and liter will also cancel out. Yeah,
Yeah. So 1 by second
there
is
will be
equal
one
to
over
k.
second.
So k is
Mm-hmm.
equal to, it is coming second inverse. Yes, yeah, no.
Second inverse. Yeah, yeah.
Yeah.
No,
So this is the
because
first order.
Mhm.
Yeah. So with the help of unit, we have to pick up that is what type of order will be there. And if they are not giving the
Mhm.
value, simply you have to, with the help of unit also, you need to determine that is it can be zero order or first order. So now let us, you tell me what is the second order. Unit of rate constant of second order reaction. Rate constant of second order reaction. Second order reaction. Second order reaction means reactant power 2.
Two.
Hmm.
So this is going to be, this will just be K is equal to 1 mole per second, a mole per liter divided by second, right?
Hmm. This one. So you are saying again, you tell me.
So 1 second. So I have mole per liter over second is equal to mole squared divided by liter squared. Um, so this will be just the same mole per liter all divided by second.
Hmm. Mole per liter divided by second. Here is, that is a little bit different. What is there? Mole per liter and power is 2. Here is the
Mhm.
history, something is different. Okay, how can you write mole per liter divided by second? Here you see what is there. It is going to be mole per liter one time in one bracket. Another bracket also you can do mole per liter, na? Mole per liter,
Yeah.
yes or no? This is yes, and here is
Mhm.
k. So what we can do here, that is mole per liter one and one will be cancelled out.
Mhm.
So 1 upon second is equal to, what is going to come, k, and here is what
Yeah.
is there, mole per liter. Okay, but they are asking
Mhm.
to write down in the term of second. So what will happen, let us see here. 1 upon second, again I'm writing here, is it will be k, it is going to be mole, okay, upon it is going to be liter. So what we can do, cross multiply it. So if you are cross multiplying, so what the value you are going, k is equal to, if you are cross multiplying, so either you write, firstly you multiply then write. So
So this is
second
going to be
k mole is
mole
equal to, it is coming to be
per
liter.
liter.
Okay,
Yeah.
so k is equal to, it is going to be liter upon, it is second and mole. So it is going to
Mhm.
be liter second inverse and mole inverse. Yes or no?
Yeah. Yeah.
So this is the unit of the second order. So here is the liter is there, there is no problem. Mole and second inverse, this is okay. This is, if
Mhm.
I'm giving you the questions, I'm giving you the question, you pick up that is the question is there.
Yeah.
You are saying if k value they are saying, this way is not, no, you go different way. Question is there, 2a plus 3b giving, this is going to give the product, 2a plus 3b giving product. They are saying the order of reaction with respect to WRT means with respect to A is 2, and order of reaction with respect to P is -1. Then write expression. Then they are saying write expression for rate constant. They are saying that is write the expression. How can you write?
So I think we can have two and then in brackets, we will have a squared.
Yeah, correct.
And then we can do plus b in brackets to the power of -1.
Hmm. Yeah, absolutely correct. Only you are saying, see, rate is equal to what is there. So they are rate is equal to K. Hmm. And they are saying that is the A. So power means 2 and B power means -1. Yeah, this power is -1. This is what the
Yep.
expression if it is given. Now the question change. Question they are saying. What is the they are saying? mm, they are saying what is order? Question they are saying what is order? What is order? Order of given reaction. Order of given reaction. What will be the order in the same? If it is given this one, okay, this is the reaction. Now they are asking what is the order. Hmm.
Mm-hmm.
Hmm. Tell me. With the help of this all the data,
Oh, this is going to be first order.
this is going to first order. Thank you. This is going to be first order. Okay. So this is all.
Mm-hmm.
Okay. Now what the major heading is there, and the major point. We have to do the many of the numericals. Okay. But before that, what is there? We have to do that is integrated. You know, integrated. It is in the syllabus. Integrated. I know. Order of rate of reaction. Form of integrated form of order of rate of reaction. Integrated form of order of rate of reaction. Okay,
Okay.
so integrated, okay, form of order of reaction. So first one they are saying we in your syllabus it is there for the zero order. Okay, zero order. Then second one is there that is first order.
Mm-hmm.
Zero and first order I have seen. Then you can have the you can go any order, but we are supposed to give that is the integrated form. So can we do today or you want tomorrow or next class? What do you want?
Actually, can we do next class? I need to have another class in 10 minutes.
Okay. Then okay. All the best. We'll see you. You got
Yes.
the problems of the mole concept like that last class you studied, na? Did you receive the mail?
Yeah,
Okay.
I received the mail. Yes. Thank you very much.
Okay. Then you will continue. Bye.
Thank you.